We're given data here for probability purposes, and the data is from a survey. So this indicates that this many people own an Apple computer. A total of 78, 68 plus 10. This many people own an HP computer. 59 of them, which is 32 plus 27. And then it says, as far as Lenovo computers, 96 respondents say that's the computer they own. And it says here, assume a person only owns one of each. That means if they own an HP, they do not own a Lenovo. If they own an iPhone, they do not own an Android. Again, for the purposes of this study. The number of iPhone users totals up to 145. And the number of Android users totals up to 88. And this gives a total, if we add 145 plus 88, 233 total respondents in the survey. If you add 78 plus 59 plus 96, that also has to total 233 for this study. If it does not, then one of these numbers is wrong somewhere. So find the probability that a person owns an HP computer. Number of successes over the total number is going to be 59 over 233. So that's 59 over 233 as the probability that people own, probability that someone owns an HP. Given that a person owns an Apple laptop. Now what this word given does for us is it changes the denominator value, because now we're only looking at the people that own an Apple laptop, of which there are 78 of them. That means our denominator is equal to 78. Excuse me. Find the probability that they also own an iPhone. So this number 68 is the people that own an Apple laptop and also own an iPhone. And that is the number that we are looking at. 68 on the top numerator, 78 on the denominator, because again, this is the number of people that own an Apple. And this is the number of people that own an iPhone, given that they own an Apple laptop. What is the probability that a person owns an Android phone or owns a Lenovo? We can see that the number of people that own Androids are 88. We can see that the number of people that own a Lenovo is 96. But if we take a look at this data, these people that are 51 of them, they own both an Android and they also own a Lenovo. So within this 88 people, there are 51 of them that are also in this category of 96 people. That means if we simply add 88 plus 96, that we are double counting these 51 people. So in order to find the probability using the OR statement, you have to find the individual probabilities, Android, plus the individual probability Lenovo. Subtract from that the probability of both of them happening. And that is going to be 88 over 233 plus 96 over 233 minus 51 over 233. Total there is going to be 133 over 233. So in this study, are the categories owning an iPhone and owning an Android mutually exclusive? Now remember, the word mutually exclusive cannot happen at the same time, right? When two categories are determined to be mutually exclusive, that means they cannot happen at the same time. And since this says assume a person only owns one of each, that means yes, these categories are mutually exclusive. And the reason is, in this study, no respondents own both an Android phone and an iPhone. So what is the probability that a person does not own an iPhone? Well, for these purposes, and if they don't own an iPhone, that means they own an Android. So that's going to be 88 over 233. An alternative way to calculate this is to find the probability that someone does own an iPhone. Right, 145 over 233. So if we take 145 over 233, let me actually write this out for you to see. If we take the probability that someone owns an iPhone, that's going to be 145 over 233. If we subtract this from 1, then that will get us the probability that this event does not happen, and that is exactly what is being asked for us with this notation. So since we need a common denominator of 233, that means we're changing this number 1 into 233 over 233, subtracting this numerators because the denominator is now the same, and that gets us to be 88 over 233.